Firstly, I would just like to welcome everybody. Thank you very much for coming. I'm quite overwhelmed by the number of people that have turned up. We've badged this as the unveiling of the bike, and I just set the scene before I talk on the presentation. Rather than unveiling the bike, we've left the bike for people to see because it's not 100% finished, and what I was slightly apprehensive of was having a bike covered up that we unveiled that you all looked at and thought, that's not finished. Why are they unveiling a new bike? So it still needs work doing. It's very much work in progress, but we're showing you where we are at the moment, and it'll be ready for the race, which is June the 12th. And also, I'd just like to say that I'm the face of the team, that the hard work has been done by these guys, the students in the team. Okay, so although I'm presenting this, please don't think I'm the one that's done it all. It's the students' project. And without the students, we wouldn't be where we are with this project. We took the decision very early on that the way to win this was to produce lightweight solutions, following Colin Chapman and his famous performance through lightweight solutions. We're running a DC motor, so it's a brushed DC motor. The batteries are lithium iron phosphate. The design speed that we did, the calculations have been done on, will give us an average speed around the track of 70 miles an hour. So that's an average speed around the track. The calculations show that on the large downhill straights, once we've reached the top of this 500-metre climb, if the rider gets far enough behind the screen, we'll touch 102. So that's the top speed. The bike itself will weigh about 160 kilos. The torque, well, I like to see it as the Bentley and the Rolls-Royce way of advertising. When you look at the torque on a Rolls-Royce, it just says adequate. Well, this will be the same. It'll be adequate for what we need to do. Okay, there's three key challenges to this. The first one, and probably the biggest one, is energy management. We need 39 megajoules of energy to go around the track. So the students have mapped out the track in terms of the flat, twisty, turny bits at the start, the uphill straight, the horizontal bit, the downhill part. That's been mapped out, and we know how much energy we need to get around that. If we work back with the efficiency, it tells us how much energy we've got to start with. The beauty of the electric vehicles is our whole vehicle efficiency is much greater than internal combustion engines. So we're running at about 90% efficient whole vehicle. Okay, so that includes the controller, the drivetrain, motors, batteries, everything. Normal motor cars or motorbikes, I'm quite generous there saying 35%. It's probably closer to 30% by the time you take everything into account. So the efficiency, so they need to start with much more energy. The reason I've put this up is the key thing, and this is why it was one of the key challenges, is when you do the calculations, if we need 40 megajoules of energy, 39 megajoules of energy, if I was to give that to you in petrol, I would be giving you 3.5 litres of petrol and say to you, okay, now go round the Isle of Man course, 38 miles flat out on 3.5 litres of fuel. That is a phenomenal challenge. Most bikes would probably take 10 litres, 12 litres to go round. Okay, so how we manage the limited amount of energy we have, because the energy density of batteries is obviously far less than petrol, it's managing that limited supply really effectively that's going to be the key to succeeding. And one of the things that we feel with LifeBat we'll be doing very well. The second challenge was, how do we put that much energy onto the vehicle when the amount of volume it takes up is a lot more than 3.5 litres of fuel? So there's a little CAD package. When we did the studies on the bike, we used two methods of CAD. We've got the more commonly known computer-aided design here, but as we sort of like to put it in the team, we knife and fork a lot of what we do, and we use a lot of cardboard-aided design as well as computer-aided design, which allows us to physically make up bits and just make sure it's all going to fit. So two elements of CAD, and that showed us a packaging first cut of what we were going to use when we were doing the batteries. Now, since this was done, LifeBat have had a little breakthrough in the technology they've managed to come up with batteries now that have exactly the same energy density, but 35% less volume. And that was a real godsend to us because we were struggling to package everything in with the previous setup, and we were thinking maybe we've got to go to a bigger bike to get everything in. But with this reduction in volume of the cell, but keeping the same capacity, it allowed us to go to something that looks a bit like that, So that was the new packaging setup, where we could fit the same amount of energy in, but cram it all in. There is one extra battery pack to go in that's not shown on there, but that was one of the key issues of how we package all this together. I put this slide up because there was a report done, the King Review, which was looking at low carbon vehicles, done in 2007, and it was particularly done to look at how we can reduce CO2 emissions. And what their findings showed that even if you look at the whole vehicle life cycle, so how we charge this, so how we get the electricity and then running the vehicle, and you compare that to the whole vehicle life cycle of something that runs petrol or diesel, you still only get 50% fewer emissions with this. Okay, so it's not the fact that because we're using electricity, that's coming from a power station somewhere and that's putting out more CO2. Okay, it's 50% less CO2 using an electric vehicle. And that's with the current grid mix of energy. If we go towards renewables and carbon capture on the power stations, then that figure comes down to 80%. 80% less CO2 with something like that. Okay, whole cycle, not just because it's got no tailpipe, it's no emissions. I'm talking about where the energy comes from to start with. The other benefit from it, obviously, is to do with health benefits. I noticed that Obama is looking at regulating against CO2 on health grounds. He announced this on Monday this week. They've decided that CO2 is a terrible contributor towards people's health, particularly asthma and the elderly, and they want to regulate the amounts that are being produced on health grounds. The aim is to have a road-going variant of this after the race. Obviously it'll be detuned, so we will only look at a top speed of 70 miles an hour, but it'll give us a range of 100 miles, which is a very viable proposition for people to use as transport. Charging is always something that's brought up as an issue. Well, the batteries within this, they will take 4,000 cycles, and that equates to about 300,000 miles on that particular vehicle. It'll charge from a standard 13 amp socket, and the sort of thing you would run on a bike would charge in 4 hours. And that's with the charger built into the bike, which is relatively small. If you had a charger at home, which was a bigger charger, then you could charge it up in a much shorter period of time, probably somewhere like 50 minutes, full charge. The cost it's going to be to you to run that is less than 50 pence for a full charge. So very attractive as a means of transport. And I am quite a keen promoter of this, because I think there's too many skeptics of electric vehicles, and if you look at the research that's actually been done and the gains to be made, I think we need to get more involved in producing road-going variants and maybe fulfill Boris's quota of 100,000 electric vehicles in 6 years. Well, we could do that with the bike very easily. Okay, the fastest. So this is the poster that's up here. I'll try and explain this. I thought the name was a good idea, but maybe it's not. The fastest, what it's about being the first. It's not about being the fastest around the track. We know we're not going to be the fastest because there's all sorts of petrol-driven bikes that will be faster than us. But it's about being first at the race. It's about being one of the first people to sign up for it.